In this video, I'm going to go over two things handling multi-threading and stride. One is the concurrent collector. This allows you, as the description says, to add items from multiple threads. The only thing that limits you is that you have to close the collection before actually using these items or accessing the underlying array. The other thing we're going to go over is the dispatcher class. This is what handles all of the multi-threaded for loops, so you can run a bunch of things in parallel. And these are the two things we're going to go over today. I grabbed down the repository I had for the pathfinding demo that I made a little while ago. They're kind of garbage. So right now, all this is just a simple for loop running through every single Pathfinder component it has in this list here. These get added when entities get added to the scene. And finally, we delay the waypoint change every second, and we check if the agent has a path. And then we give it a random path to run towards within an area of negative 100 to 100 on the X and Z axes. So let's run this and we'll see what the performance is like right now. This is also spawning 20,000 entities, all with pathfinding. So there's quite a few. This is an extreme example, but you can see here we get stuck around 100 to 110 FPS. And if we open up the profiler here that I have running in the scene, there we go. We can see here that the Pathfinder is usually averaging around 6 milliseconds. Should be a max call is about 7 to 8, and the minimum is about 5.5 milliseconds per frame, which is pretty slow. You don't really want that because the higher this number goes, the lower FPS you have, because it's running each of those systems. It's taking that long to render a single frame. So the lower you can get that, the better. In this case, 100 FPS is pretty good, but I'm on a pretty high-end machine, so obviously this will not apply to everybody, and some people have a harder time running. So let's see one of the things we can do to improve the performance. Stop this from running. So the first thing we're going to do is we're going to go to the pathfinding processor where that for loop was, and we're going to change this for loop to the dispatcher class. And that is super easy. I'm going to this out. I'm gonna add a new line here. We're gonna call the dispatcher, and you got to be careful here. You want to make sure you do stride.core.threading, and this allows you to access the for loop. Go here. You're gonna do so you want to do from the index, the starting index point, which we're gonna do 0. So you can also call this batches if you wanted to, and then we're gonna want to do the count of the list size. So we'll do components. Oops. Stops working now. Dot count. And then we're going to have the same thing as the index operator that you'd have in a regular for loop. So we're just going to do I, and we're going to make a anonymous method. Open the curly bracket here. Close that off just because I hate seeing regular wigglies. And we're going to thread the first two methods that are being called per the Pathfinder on the component. And I'll tell you why in a second why we're only doing the first two. Components I, Pathfinder move, and rotate. And it's because this delayed waypoint change has direct access to the set waypoint method, which is being called in the Pathfinder processor, or not the Pathfinder processor, but the navigation processor, which is running on the main thread. So if you call it from multiple threads, you will get an error. So what we have to do for now is we want to take a for loop, and we'll do that, and there we go. Copilot has my back. We're going to delay the waypoint on the main thread, but we'll do the movement and rotation on every single other thread that is available. And we'll run this again, and we should immediately see some pretty big performance increases. And in all honesty, this is probably enough for a lot of people. So we can see already we're hitting about 200 FPS, 230 FPS. Love seeing that. And we can go back here, and we can see here the pathfinding processor is now only using about 1.5 milliseconds at its peak. It's peaking around, I saw 4 milliseconds there for a second, which is huge. We've gone from 5.5 milliseconds to 1.5. So already a massive performance increase, but let's say you wanted to multi-thread the delayed waypoint change as well. So the main issue we have is this method here, and the random. Because we're setting random within the processor, it is also being set on the main thread, so we will have to fix that issue as well. So the easy one right now is this random has a fantastic thread safe instance. So we're going to do this. We're going to access.share, and this is literally just a random method that is available on each thread. Nothing extra you have to do here. This just works out of the box thanks to .NET, which is fantastic. The next thing I did, and I did this ahead of time to save some time, I created an iCommand interface. All this is just a method that executes, and what this is going to do is it's going to allow us to call iCommands on the main thread. So if we wanted to queue up a bunch of work that was on multiple different threads, we can send them back to the iCommand array and set them to run after the multi-threading is all done. And to do that, I created the change waypoint command. And this has the set waypoint, and it just sets the waypoint in the execute method, and we're good. So these are very simple. This is fine that it has a set waypoint because this will be executed after multi-threading is done. And I'll show you how we do that. So the first thing we're going to want to do is we're going to want to create a new list type. Not exactly a list, but it's a private read-only. And it's not a list. We're going to do concurrent. Not concurrent collector. And we're going to do a concurrent collector of I commands. And sure. That would do an I command of the one we want, because there is an existing one that's there, so you probably could name that better if you wanted to. I don't care. This is just for the demo. And new. So that read only is valid. Now, what we can do is we can go back down to here. What we can do as well is just copy that, paste that over there, get rid of the for loop, and we'll go down to our delayed waypoint change and replace this call with commands dot add new waypoint change waypoint command, and we're going to add the component, and we're going to add the new waypoint. So these get passed into here. These get queued up from each thread concurrently, so it doesn't have any threading issues, at least that I've found so far. And we can call it after this is done, so that at least now, although this is still technically single-threaded, we now have the random being multi-threaded, and we have this if check being multi-threaded, which is great. I probably could do this better too. This might cause an issue, but we'll see. I don't have issues yet, so it might just be getting lucky without the race conditions. So finally, what we're going to do is, because these commands are still waiting for threads to access its data, we need to close it so it's so it consolidates all of the the array together so we can access it from the main thread. So we're going to close this. All this does is now allows us to access the array and do whatever we want with it. So we're not going to do that. We're going to do this commands dot count, and we're going to loop through every single command that is available. Commands I dot execute, and then finally, once all these commands are done, we can do commands dot clear, and this wipes the list. And we'll actually do it has an option here I forgot about. It's a fast clear versus a full clear. Fast clear, I'm pretty sure it just wipes the index, so it'll just overwrite anything that exists, which is good enough for what we want. And that's it. I think that's everything we need. So now if we go ahead and run this again, we now have a little bit more multi-threading, plus a way to call some thread safe commands. And the performance might be a little worse because of that command list. It's important to keep in mind that you may not want to have that command running every single frame. So if every single one of these entities was queuing up a command, it would be running at like 2 FPS right now. But because we're waiting for each entity to finish their path, and we're waiting a second before we try to even queue up a new waypoint, it's not as bad. But you do see it spiked from like 200 to 280. I think I saw at one point there. So it can be pretty bad if you don't keep it in check. But if we check here, the pathfinding processor, we can see we're spiking around 1.4, so 1.5. So it's not much worse than what it was before, which is perfect. It's exactly what we want to see. And that is it. I think that pretty much covers the basics, at least, of the dispatcher class, as well as a simple use case for the concurrent collector. So that's pretty much it for the video. What we've done today, so we've gone over the dispatcher.for. There are a few other for options, the dispatcher class, that you can use. They all follow a very similar format. There's a for each where you can pass in just the array itself and then have the anonymous method called a little easier. I found it a little slower than the dispatcher.for loop, so I use this usually when I can anyway. But it is available if you want. And that's really it. This dispatcher.for has been extremely useful. It's faster than parallel.for by quite a bit. There seems to be some overhead when calling parallel by about 2 milliseconds. So just without even having a list available, it adds 2 milliseconds to the update time, which is not great. This does not have that issue. It adds like a 0.0 some millisecond delay. So much prefer the dispatcher over parallel. The other thing we've gone over is how to queue up commands safely with using the concurrent collector. Thanks to this, we can have a list that is completely thread safe. Again, as far as I've found, I haven't had any issues, but please put it in the GitHub if you find something. And we can call these commands just by closing it after the multi-threading is done and accessing the array and then clearing it once all the things we need to access. That's it for the video. If you found this helpful, leave a like. If you have any questions, feel free to ask them below. And thanks for watching.